Hey guys, David here and welcome to another video. Today we're going to have a look at the Watcher guitar build that I just recently finished. And in this video I'm going to go much more in detail. If you haven't seen it already, I released a kind of build montage of it. But in this video I'm going to show you exactly my design process, how I laid out the cam, how I machined it and built it. Now this is of course going to be a much longer video, so feel free to use the timestamps down below to find the parts that you are the most interested in. But before I get started, I want to give a big thanks to PCBWay for sponsoring this video. They make super high quality PCBs at a very affordable price. So if you want to do any sort of electronics prototyping, they're the way to go. Also, they have manufacturing services. So if you need anything 3D printed, either in resin, in regular plastics, engineering plastics, metals, whatever you can think of, or CNC machined, then they have a very affordable service that can do that for you. So if you have a part you need for a project that you just can't make yourself, have a look at their online quotes and you will probably be surprised how affordable it is. So big thanks to them for sponsoring the video. Make sure to check them out down below. Now, first and foremost, this design, of course, is not just created by me. It is inspired by various other guitars, and that's actually how I started the modeling process. I put in some of my inspirations. You probably have already guessed that Strandberg is one of the inspirations, and like the kind of bottom half of the guitar is heavily inspired by Strandberg. I mean, they're one of the biggest headless guitar manufacturers, and I really like their ergonomic shape. But on the more upper sides with the horns, the guitar that much more inspired me is the Solar guitar. I quite like my Solar S-type guitar and wanted to do something inspired by that. It's more akin to the A-type with these deep cutouts here. But the idea of merging a Strandberg and a Solar guitar, that just really appealed to me. I also put in a guitar from Skeversons, and that just gave me some more references of like a different headless design and kind of the differences. It's quite astounding, like the size differences of different areas. Like I roughly aligned the 24th fret here, and the back part where your leg sits against, like there's quite a big difference. So that just kind of give me a bit more confidence in modifying some shapes. If there are commercial examples in both directions, if I'm somewhere in the middle, I'm probably going to be good. Now after that, I just started kind of modeling out the rough shape using a bunch of splines and making sure to get all the scalings properly configured. This here is kind of like my main original sketch. As you can see, quite basic, but I spent hours going back in the sketch, adjusting these splines ever so slightly, making sure that the curves flow nicely, that there's no weird kinks in them. But that's just something that it's very easy to go back and forth in Fusion as it like nicely updates and everything. Now you can see that I chose to angle the pickup. Some guitars with multi-scale do, some don't, but I decided that it looked better, and it's a very slight multi-scale. I haven't even mentioned it, but on the high E string it's a 25-inch scale length, and on the low E string it's a 25.5. So like quite a small difference, but it still just makes it ever so slightly more comfortable to play. And apart from that, I just really like the look of a fan fret. That's one of the main reasons as well why I chose to go this route. Having a look at the guitar from the back, once again I borrowed a lot more from Strandberg in this regard. For one, there's the like electronics cavity and cover. I basically got inspired, let's call it that, by them to have the output jack here integrated, and this is like one piece of aluminum that is just bent here, and that just creates a really easy way to mount the output jack and kind of out of the way. Now, I do wish I had angled it slightly more this way, as the way I like to sit with this guitar, the cable coming out here does get bent slightly, but if I ever make it again, I might angle it slightly more this way. I think in the Strandberg it is just like slightly more this way, but then it still works this way, but it's something that might change in the future. And the other thing is, of course, that there's quite a bit of cutaways back here as well. This guitar is already quite thin at only 37 millimeters, but I still wanted to have even more high fret access, so I kind of did a cutaway here to where it meets at the heel, and of course sculpted all of that as well. Originally I was wanting to make a neck-through guitar, as I really like the neck-through on my Solar, but I realized that the entire neck length does not quite fit on my CNC, so that was out of the question. And in retrospect, I think a set neck construction was a good idea. I had started modeling it with screws, so like a bolt-on neck construction, which is why there's still some remnants here of where I was not able to fully cleanly remove that aspect of the design. But I think the set neck is better here since it is quite thin already. But with the set neck, there's like a big contact patch, and thanks to the CNC, it fit very well as well. So I have no worries about the connection here. Moving up the neck, this is like fairly standard C-shaped neck. For the thickness, it is 21 millimeters at the where it meets the body, and 19 millimeters up at the nut. So relatively thin, but nothing crazy in any regard. And although it is a headless guitar, there still is kind of like a mini headstock. I don't like the idea of just cutting it off. For one, I feel it looks not really nice. And also, when you slide your hand up to the first fret, then it's quite nice to have something to feel that you have arrived, and not just kind of slide off the end of the neck and have to find the neck again. So that's why there is this kind of raised part here. And actually, in the future, I might even make that slightly larger. For one, it kind of looks cool, and two, it just adds a bit more to the feel. I also try to keep this area here very short, but here this part was almost too short. I like to string it by having the ball end of the string come through here and then clamp it at the bridge. But with some strings where the string is wound onto the ball end, it kind of still sits on the nut, so you have to trim that back a bit so the intonation doesn't get weird. So in the future design, I will move that just back by like 2 or 3 millimeters, and that would totally fix the issue. Now, finally returning to the bridge system, I was expecting Headless Hardware to be a bit more expensive than regular hardware, but when I really looked into trying to find out which hardware to get, I was actually gonna go mainstream, go with one of the bigger brands to really have some quality hardware, but I was not prepared for just how expensive Headless Hardware is. So I did end up with the upper end of the cheap AliExpress import stuff. They claim it's like some made in Japan thing. I'm not too sure about that, but it is not the very cheapest one off of AliExpress. I would highly doubt that works at all. But having seen these in person, I do understand now why they are just so expensive. Like a cheap set of Headless Hardware is like $300, and this one was like roughly 100 shipped, which is very expensive for Chinese import hardware, but there's just a lot of complexity to these parts and a lot of fits that have to be quite precise. Now, they aren't all that precise on this hardware, but I was able to replace some of the screws that hold it together that just were not high enough quality, and some of the hardware included was brass that really needed to be steel, so I had to replace that, and I added some little 3D printed inserts here that made the whole thing feel a bit better. And with that, it is absolutely usable. Like, it holds into tuning, you can intonate it, set the string height, all of that. So that's not an issue at all. The part of this bridge that I actually really like is that you can lock the string here, and instead of feeding the ball end through here and then locking it out at the top, you can lock it here at the bottom, and you don't have any risk of getting yourself poked with the ends of the strings. That's apparently an issue some people have with the Strandbergs, where you cut the string at the top and then it can be a bit pointy. And these little string catchers here at the top that hold it in place, they are really nice. They have one screw hole and a pin that goes in. They sit perfectly. They look high quality. I really like those. Probably better than some of the other options out there. They also have set screws, so you could lock it up here, but I just feed the ball through, which sits nicely here, and that works perfectly. I just kind of tightened the set screws to not have them fall out, but they're really not required if you have the ball at the top here. The only last kind of special part of the design, I guess, are the scallops that I added here. Those were just for fun. I wanted to try a scallop guitar, and I think it looks kind of cool. I ended up with kind of not very tall frets, because those were the only ones in stock, and I didn't really pay that close attention. So the scallops ended up being a really good addition, as I kind of rub against the fretboard on some of the other frets. But otherwise, like, I'm not a big scallop fan or anything, but I think they look cool, and it was something cool to try out. And since I'm making it on the CNC, like, they're literally not any extra work, and it came out quite nice. Speaking of the CNC, let's move over to the manufacturing tab. Starting off with the body, I made it out of a single piece of European ash, and then added this veneer on top. But let's for now hide the veneer first. And as you can see, it's not that difficult, but there is some 3D geometry. So started off with a facing operation with a fairly large tool. I think it's a 12mm end mill here. So basically the biggest that I can put in my CNC, apart from like a big face mill. Just to get the top nice and flat, and my blank was also a lot thicker than I needed it. So that got rid of a lot of material. Then I added a bit of a locating feature here, since all the edges are kind of rough. I wouldn't have a good place to pick up the 0 origin again if for some reason my machine shuts up and loses its origin, which happens not often, but enough times that adding this little feature of a convenient locating point is definitely worth the trouble. Didn't end up needing it, but it's a good insurance policy. Then I added in these bores here, and those are for a locating dowel when I go ahead and flip it over. Just a very simple bore that will fit an 8mm dowel pin. Now I ended up using an end mill because my dowel pins didn't arrive in time, but the idea was to just use some dowel pins while flipping it over. Then just routing out the pockets with 2D adaptives and going around the perimeter with a contour. Just simple 2D pocket operation for these parts here, nothing too special. And then for the 2D contour of cutting through like the top half of it, one thing I did here is to not just go around it, but, well, of course, go down in multiple step downs, but also have like roughing paths. This just creates a slightly wider slot that allows all the sawdust to more easily escape, and you don't have to sit there like a hawk with a vacuum cleaning it out so that your bit doesn't get stuck. This is very simply done here by just clicking roughing passes and doing a step over here. Now I also had to put step over up here. I'm not sure exactly which one it uses, but it's easy enough to do on just one step over, and then it like goes down at each depth and does these 2 passes. Now this of course doesn't go all the way through yet, but that's just on the top so that I can come here and clean out the heel, and then do the like 3D surfacing of the little bevels and everything up here. The final cutout then will be done on the backside. Here the adaptive strategy again to hog out the material for this joint, and then 2D contour. This one I at first had a little offset, and then just went back and stuck up on the fit, so I actually made the neck first and then the body afterwards. I'm just showing it in reverse order now. But this allowed me to have this pocket fit exactly with the neck and be a nice snug fit without having to do too much sanding. Then before going in with a ball end mill, I did a adaptive strategy here to clear away all of the material. And a little trick here is to use stock contours here and select your outline shape. You can use the shape from the sketch, for example, and that will just contain the tool nicely. Then finally is the surfacing of all of the top 3D surfaces. I'm using an 8mm ball end mill for this, and the way I contained it here is by choosing the avoid touch surfaces feature, and basically chose everything that does not need to be touched by this ball end mill. And by also choosing the sides here, I can machine this round over, but without having the tool go down and waste a bunch of motion. With that, I can flip it over. First, drill some locating holes in my spoil board that will then fit the dowels. And on the bottom side, it is more of the same facing, locating feature, and then some cutouts. Let me quickly hide this panel. Here I have to make sure to use a slightly longer tool. I didn't want to have too much stick out for the other stuff, but here this pocket is quite deep. It's like almost 30 millimeters, so I had to have a tool with quite a bit of stick out to be able to reach all the way in there. But that was just something to keep in mind. I almost didn't remember that and crashed my machine into here, but luckily I did a test piece first. Then going through, not yet quite all the way, but just around again, so I can do all the 3D contouring and beveling, but not quite yet matched to the other side, so it still holds in strong. And I had like some screws holding it to the to my spoil board on the perimeter, in addition to some double-sided tape underneath. Then again, adaptive strategy to clear away the milestone material. Also in here for the output jack. And then after that, I cut out the perimeter all the way, leaving some little tabs in addition to the double-sided tape that is underneath. And then once again, a scallop toolpath to finish all of the 3D surfaces. And on the very end, some drilling for the screws for the pickup cover. For the electronics cover, I mean. For the neck, it was actually fairly simple. On the top, it only needed the truss rod slot, so there was no need for any fancy locating tricks, as I was able to just cut in that slot, and this one doesn't need to be perfect. Like locating off of the edge is perfectly fine, as long as I'm within like a millimeter. This truss rod slot is perfectly adequate. Here on the back is the only place where it needs to match up with the hole that I drilled, but I drilled that manually afterwards, so I could just make sure that it goes in the right place and not have to worry too much about locating it perfectly while flipping it over. Then on the bottom, I started out with doing the contour. Then just like with all of the other stuff, an adaptive to clear away most of the material, and two faces to face these two surfaces here nice and flat. And here, instead of a scallop, I used a parallel tooth path and just went back and forth across the neck. Looking at this in the CNC is quite fun, especially sped up. It looks very satisfying to see how this neck gets machined. Now, whenever you're doing any kind of 3D surfacing, the big trade-off is machining time versus end surface finish. Now, I ended up here with a 0.7 millimeter step over, which is fairly large, but that meant that the surfacing wouldn't take ages. But of course, there was a little bit to sand off, but I was going to do a bunch of sanding afterwards anyhow, so these little ridges left by the tool are not really an issue. But this way, it only took 10 minutes to machine the back of this neck. I could have gone for a much smaller step over and spent 20 minutes on it, which would result in slightly less sanding, but was really not necessary. Now, the fretboard I had a bunch of issues with, but they were not really related to the CAM side at all. The CAM is once again very straightforward, just perimeter, some flat spots, and then a parallel toolpath once again to do the radiusing and cut in all of the scallops. Now, up until here, it's very basic stuff, but what caused a lot of problems already in this area is that the Ebony that I got for this was kind of warped in the beginning already, so at first I had to do an additional facing of the backside and to be able to even hold it down at all. But then after I had removed some more facing and parallel toothpath, it warped again, and it warped in all kinds of places. In the end, was kind of badly warped, but I couldn't really fix it anymore, so I had to do a lot of hand finishing on it. But I guess that's just the piece of wood that I got that had a lot of internal stresses, so when I removed material from it, it wanted to just warp in all kinds of different places. All the other pieces of wood I had were really good in that regard, but the fingerboard just did not want to cooperate. For the fret slot, I'm using a trace operation of the actually drawn on sketch of the line. If you want to go all the way through, it's a bit easier, but I wanted to have these like hidden tanks, so I made a 3D sketch, or like first a 2D sketch of just the fret locations, and then projected it onto the surface, and then used the trace operation. Now this is a tiny tool. It's a 0.5 millimeter end mill, so I had to go really slow at high RPM and very, very small step downs. I went down in 0.2 millimeter step downs and took it slow and gently. And after I kind of found a good speed, and I was able to cut the entire thing without breaking a tool, but I did break a couple tools trying it out, and also broke one tool just kind of brushing up against it with my finger. That's how fragile this tool is. Now, one big mistake I made in this build is by making these slots only 2 millimeters deep, which is exactly the depth that they need to be in the end. This caused me a whole lot of trouble while fretting, and it's why I might have to refret this instrument. I should have actually gone down at least 2.5 millimeters. So after some sanding and everything, the frets can sit in fully without hitting the bottom of it. But live and learn. Next time, definitely going down deeper. Now, depending on what kind of frets you get, you might have to have two offset cuts. Mine needed a 0.58 millimeter width of slot, so I had to actually do two traces. And maybe I could have gotten away with just one, but it was tight as it is already, so I just duplicated this whole thing and moved it by 0.8 millimeters. Then finally, to cut out the inlay shape, I used the same 0.5 millimeter tool, which took a while, but this way I was able to get nice sharp corners and get this done. The toolpath I used here is morphed spiral, actually, because it's a 3D surface that I needed to machine, so just a 2D pocket would not work. And I just defined the shape of it and set the machining outlines as my shape. And then this worked out quite well after the depth was set right, and the positive part that I inlaid in here, I just cut out on the laser cutter. The only other stuff that there is would be the electronics cover. For this, I used the sheet metal functions inside of Fusion and then created a flat pattern. This allows me to model it nicely bent up and that, but then have it in the proper shape where I can machine it. Just made this out of some 2mm aluminum, very basic, just kind of outlined, spot drilling, chamfering, all of that good stuff. Yeah, cutting thin aluminum like that is no issue at all on the Killer Bee. So cutting that out took, as you can see, minute 14. So very quick to cut that out, and it worked out quite nicely. Now, I didn't set enough of an offset. I should have done like negative stock to leaf or model this slightly smaller. So it didn't quite fit in the pocket right away. I had to do some filing around the edges, but that's just one of those things. You make that mistake the first time, and then next time you remember that you do want probably about 0.5 millimeter of tolerance in between, so that just everything fits in nicely, especially after there's some finish applied and all of that good stuff. It's a lot easier if you can avoid that work, but also not that hard to do after. As a last finishing touch, I also decided to machine a knob, but that's once again, just a face and two bore operations. And this then results in this guitar. Putting it together was relatively straightforward. A lot of hand sanding, and I don't have a lot of woodworking tools. That's just why I used so much of the CNC for this. But just used an orbital sander to do some of the rough sanding and a lot of hand sanding and filing to just get all of the scratches out. To glue on the fretboard, had to use like quite a bit of force to get it to sit nice and flat, and still in the end there were some gaps that I filled in. Definitely not ideal. Maybe in the future I should glue it on to the neck before I surface the top. This could be one way to avoid it warping too much, or just have it be nicer in the end. The other thing, I guess, that is not as obvious directly from the video is the finishing that I used. First, I used just some wood stains to get the color that I liked. Used black on the entire body, then sanded back the center of the top to get kind of a burst. And then used some orange to get a bit more color. I also used an airbrush to get the burst to like properly fade in nicely. That works quite well. Then to finish off, I applied some crimson high-build guitar oil, and there you really want to make sure to follow the instructions to a T. I didn't follow them too nicely in the beginning and ended up with too thick of a layer, which took forever to cure. But putting on a nice layer, letting it dry for like 10 minutes, and then rubbing off all of the excess and just repeating that about 8 times, roughly 2 to 3 layers a day, will lead a very nice result. And with that, if you haven't seen the original video, the like montage, there is also playing demo. I'm not going to repeat it in here since, well, you already saw it there, and I prefer to just play for myself instead of out on the big YouTubes. But with that, if you have any more questions, leave them down in the comments and I'll gladly answer any more detailed questions to the entire building process. I will also leave some links down below to some other great channels that have helped me along the way for Fusion modeling tips, for CAM tips, all of that good stuff. Also, once again, a big thanks to PCBWay for sponsoring this video and helping to make these projects possible. With that, thank you guys for watching, and I'll see you next time.